In this video, we'll discuss SCT 3.4 Analytical Techniques paper. Under that, Block 1, Unit 2. In that, Unit 2 covers chelating ligand, structure of crown ethers and crypt, novel crown ethers and important properties, crown ethers and cryptonds, some synthesis of sepulchrates, anionic crypts, inorganic crypts, solid phase extractions, multimodal solid phase extractions, the principle, procedure and equipment, and advantages and applications of microwave assisted extractions, selection of solvent, and advantages of microwave assisted extraction. Crypt or crown ethers constitute an important and interesting class of complexing ligand. Apart from metal complexes, a variety of unusual species, among which alkalides and electrolytes, was made possible through them. They require special mentions. The crown and crypts are enormously studied due to their increasing applications, varied chemical and physical processes. What are the role of this chelating ligand? Many essential biological chemicals are chelates. That chelate play important role in oxygen transport in photosynthesis. They act as catalyst. In addition to their significance in living organisms, chelates are also economically important, both as product in themselves and as agents in productions of other chemicals. A chelate is a chemical compound composed of a metal ion and a chelating agent. A chelating agent is a substance whose molecules can form several bonds to a single metal ion. That metal ion, it undergoes different oxidation state. It is easily to formation of these chelates. These are all some common examples of this chelating ligand. We consider single molecules like the single ions like nickel, that is bonding with that ethylene diamine can form two bonds to a transition metals such as nickel or whatever iron, anything. In these two structures on the left, the bonding capacity of Ni2 plus ion is completed by water molecule. Each water molecule forms only one bond to Ni2 plus. So water is not a chelating agent. Because the chelating agent is attached to the metal ion by several bonds, chelates tend to be more stable than complex form with monodentate ligands such as water. Forpine is a chelating agent similar to ethylene diamine, in that it forms bonds to be metal ion through nitrogen atom. Each of the four nitrogen atoms in the center of the molecule can form a bond to a metal ion. Consider another one is chelate is vitamin B12. That is also a chelate. It is the only vitamin that contains metal cobalt ions bonded to porphyrin like chelating agent. As far as known, it is required in the diet for all higher animals. This is the chelating agent of a particular economic significance in ethylene diamine tetraacetic acid. EDTA is a versatile chelating agent. It can form 4 or 6 bonds with a metal ion, and it forms chelates with both transition metals ions and main group ions. We consider that calcium complex with EDTA molecule to formation of that chelating molecule. In other applications, EDTA dissolves the calcium carbonate scale deposited from hot water without use to corrosive acid. That's why in that purifications of this water molecule, determination of calcium and magnesium, generally we have to use EDTA titrations method. The dimer caprol is an effective chelating agent for heavy metals like arsenic, mercury, antimony and gold. These heavy metals form particularly strong bonds to the sulfur atoms in dimer caprol. The dimer caprol was originally employed to treat the toxic effect of an arsenic containing mustard gas called levisite, which was used in World War I. The chelated metal cannot enter living cells and is rapidly extracted from the body since dimer caprol is water insoluble. It is dissolved in an oil base and injected intramuscularly. The structure of these crown ethers and crypt. The study of crown ethers grew enormously after Pedersen's finding of crown ethers and their abilities to bind strongly with metals ions in 1967. That is the theory of that crown ether and crypts. Consider example that is very important in the point of examination. The biological systems employ crown and crypts widely, especially to understand the perplexing and very efficient selective between sodium and potassium ions. Crown ethers are known as group of macrocyclic polyethers. The structure has ethereal oxygen atom are separated by 2 methylene group. Example, crown ether is 3, 11, 12 dibenzo, 1, 4, 7, 10, 13, 16, hexa, acylo deca 2, single 1, 3, 1, 1 diene, which is designated as dibenzo. That structure of these 18C, 16 or crowns 6 are mentioned in that figure 1. Many macro polycyclic ligands which are related to each other are also known as and are called what? Cryptates. There are more potent, stronger and selective complexing agents for alkali metals. Crypts contains nitrogen, oxygen and sometimes phosphorus and sulfur atoms in their core structure. Consider that crypt is the molecules called crypt 222 having the basic structure that is also given in that figure 1. These are all what graphic structure of 18 crown 6 macrocyclic polyether. The cavity size depends on the size of the ring. The metal cation which is appropriately size is trapped in the cavity to forming a stable complex. Similarly, the figure 2 is also mentioned. The novel crown ethers and important properties. The crown ethers having other varied and unequally interesting functions or at the crucial stages of development. Consider this figure 2. This is the structure of crown ethers. Effort in research areas have also been made to enhance the ion capturing ability of crown ethers. The lariat crown developed by Professor C.Z. Shinkai, that is Japan University, it uses this chain wrap around ion fixing the complex so that ion won't escape. Taking the idea a level ahead, another professor, Jean-Marie Lane, is the France, double cyclic crown ethers, according to his and his team, gave the molecule cryptand its name after the Greek term crypto. The two rings of cryptonds provide extra strength to hold the ion. Crown ether surrounds an ion, a cryptand locks it up. The ion's capturing capability of a cryptand can reach up to 100,000 times more than that of 18 crown 6. This is cryptand, this is a cation, this is a cryptate complex molecule. This cryptand capturing an ion and picture of another cryptand. The synthesis of crown ethers and cryptands. It is very easy to prepare that by alkyl phenolic ether. The first synthesis of crown was achieved. Instead of the expected product, the contaminating catechol present in the reaction mixture. Formation of a different product was observed by this chemist. The isolated product was found to be dibenzo 18 crown 6. Numerous other crowns were subsequently prepared in Pedersen laboratory. Later on, Pedersen followed the synthesis and characterizations of a variety of crown and crypt as well as their metal complexes, like that speckle crates, anionic crypt, inorganic crypts. What is that speckle crates? These are all multi-cyclic encapsulating ligand called speckle crates, which are related closely to the football ligands. These are synthesized around a metal ion which cannot be released. The condensation formaldehyde and ammonia onto the nitrogen atom of cobalt En thrice 3 plus means ethylene diamine gives rise to a speckle crates containing tris-methylene amino caps on opposite faces of the coordination octahedron. The speckle crates are stable over large pH ranges. This makes the investigations of solutions chemistry of elements like molybdenum, tungsten, which are prone to hydrolysis and polymerization by changes in pH. The anionic crypts. Although cationic crypts has dominated in its complexes with alkali and few other metal cations for long time recently, there is anionic crypts. The outer charge is having a negative charge, that is anionic crypts. Inorganic crypts may also surround a metal cation completely. They are of organic origin, just like the crowns and crypt. One such compound reported by Oechtle and Weber is, repeat this, heteropolytungstenate. That is what inorganic crypt completely surround the sodium ion. This compound is reported to have antiviral activity. What are the important applications or uses of these crown ethers and crypt? This is used in that enormous applications like solvent extractions, phase transfer catalysis, stabilization of uncommon or reactive oxidation states, the promotions of the other improvable reaction. These are all some important applications are mentioned here. Enhancement of solubility of alkali metal, Next, various gentle salts containing alkali metals. On crown ether can also act as second coordination sphere ligands. It is known to produce a crystalline compound. Next part of this, introductions to solid phase extraction. Solid phase extraction is one of the analytical techniques for the sample preparations that concentrate and purify analytes from solutions by sorptions onto a solid phase, followed by elutions of the analytes with a solvent. In the traditional method, the sample preparations involves sample dissolution, purification and extractions that were carried out with liquid extractions or solvent extraction. The disadvantages of liquid extractions includes that use of large volume of organic solvent. It creates emulsions with aqueous solvents which are difficult to extract. Liquid extraction is not easily automated. It involves cumbersome glasswares and cost. These are all. The alternative approaches to liquid extractions to remove analyte quantitatively from solutions and completely recovers it in an appropriate solvent. Purifications of analytes, the removal of analytes from interfering compounds, concentrating the analytes in small volume of the solvent. The multi-solid phase extraction. The solid phase extractions normally takes place using one device with a single sorbent. However, if more than one type class of compound is present in the aqueous sample, then multimodal solid phase extraction can be used. The multimodal solid phase extractions can be done in one of the two ways, either by connecting to alternate phase by having two different functional sorbents present within one cartridge. What is the basic principle of this solid phase extraction? Solid phase extractions normally involves bringing an aqueous samples into contact with a solid phase or sorbent, whereby the compound is selectively adsorbed onto the surface of the solid phase. The solid phase sorbent is usually packed into small tubes or cartridge. By careful selections of the sorbent, the organic compound should be retained by the sorbent in preference to the other extraneous materials present in the sample. These extraneous materials can be washed from the sorbent by the passing of an appropriate solvent. Subsequently, the compound of interest can then be eluted from the sorbent using a suitable solvent. The solvent is then collected for analysis. The solid phase extraction procedure. It involves 4 steps. The conditioning of sorbent, loading step, washing of sorbent and elution. This condition solvent, apply sample plus analyte here, interface elutions, that is eluted interferences, analyte elution. The conditioning of sorbent. In this step, a solvent is passed through the sorbent to wet the packing material and solvate the functional group of the sorbent. During this process, air present in the column is removed and white space are filled with the solvent. The loading of the sample. In this step, the sample and analyte are applied to the column. The mechanism of retention holds the analyte of the column while the sample is added. The mechanisms of retention include van der Waals interactions, hydrogen bonding, dipole-dipole forces, size exclusion, cations and anion exchange. During this step, analytes are concentrated on the sorbent. Similarly, some of the matrix compounds may also be retained. Washing of sorbent. In this step, a suitable solvent is used to remove the sample matrix and other impurities from the interstitial spaces of the column while retaining the analytes. If the sample matrix is aqueous, an aqueous buffer or water organic solvent may be used. This is elutions of analytes. In this step, an appropriate solvent is used to disrupt the analyte sorbent interaction so that analyte is eluted from the sorbent column. The eluting solvent should remove as little as possess of the other substance sorbed on the column. This is solid phase extractions equipment. This is disc, cartridge and single barrel. There are three types of column or apparatus used in solid phase extractions. These are disc, cartridge and syringe barrel. Among them, the syringe barrel is the most commonly used for SPE. It consists of 20 micrometer polypropylene A, the bottom with 40 micrometer sorbent material and 20 micrometer polypropylene prits as the top. This is a solid phase extractions cartridge. It can be further classified as single and multiple cartridges. A brief description of these given is below. The single cartridge, the most common arrangement is the syringe or cartridge, usually made from polypropylene, with a wide entrance through which the sample is introduced and a narrow exit. The multiple cartridges can simultaneously proceed. In both cases, a vacuum pump is required for the movement of solvent or samples through the sorbent. The types of sorbent and modes of interactions. Mainly, there are three types of sorbent used in solid phase extractions, namely normal phase sorbent, reverse phase sorbent, and ion exchange sorbent. The normal phase sorbent means it consists of a stationary phase that is more polar than the solvent. When sample is an organic solvent containing the analyte, the normal phase sorbents are used. Polar interactions such as hydrogen bonding, a dipole-dipole interactions are the primary mechanisms of the solute retention. The sorbent have the polar functional group. The polar nature of these sorbents means it is more likely to retain polar compounds. Example of these: alumina, silica gel, cyano, amino, diol, etc. A reverse phase sorbent. There are packing materials which are more hydrophobic than the sample. These sorbents are commonly used when aqueous samples are involved. The mechanism of interactions is van der Waals forces and occasionally secondary interactions such as hydrogen bonding and dipole-dipole interaction. The sorbents have the non-polar functional groups, and these are more likely to retain non-polar compounds. Octadicyl, that is octyl, acetyl, ethyl, graphatized carbon, etc. These are all example of reverse phase sorbent. That ion exchange sorbent. Sorbents have either cationic or anionic functional group. When these functional groups are in ionized form, attract a compound of the opposite charge. A cation exchange phase such as benzene, sulfonic acid will extract a compound with positive charge. An anionic exchange phase will extract a compound with a negative charge. What are the factors affecting the solid phase extraction? The nature of the sorbent, choice of solvent, and flow rate of sample. The flow rate of samples through the sorbent is very important. It is to passed in flow will allow minimum time for compound sorbent interactions. This must be carefully balanced against the need to pass the entire samples through the cartridge or disk. It is normal, therefore, for solid phase extraction cartridge to operate with a flow rate of 3 to 10 ml per minute, whereas 10 to 100 ml per minute is typical for the disk format. What are the advantages of this solid phase extraction? The amount of solid, the amount of solvent, the amount of solvent required for the cleanup is greatly reduced, and having savings times for evaporate concentrations, minimizing exposure of analyst to the toxic solvent. The final elute has less interfering materials, accuracy and precision be improved. The samples prepared by SP can easily be analyzed by different techniques. It is a sample, simple and safe to use, ease of atomization and high recoveries of the analytes or purified extract. What are applications of this solid phase extraction? There are so many applications: environmental, clinical, pharmaceutical samples, preparations and purification. The concentrations of trace organic pollutants from water, purifications of drugs and abuse from blood and urine, extractions of organic compounds from food and beverages, impurity profiling of pharmaceuticals, applications to biological fluids. The microwave assisted extraction. The microwave assisted extraction is a process of using microwave energy to heat solvents to contact with a sample in order to separating analytes from the sample matrix into the solvent. This technique is used for the extractions of organic compounds from solid samples. Previously, microwave ovens are used to digestions of samples for metal analysis. All microwave further, they are found in the home or the laboratory, operate at one frequency. The selection of solvent. The selection of solvent for microwave assisted extraction is essential. The solvent must be able to absorb microwave radiations and thereby becomes hot. The ability of an organic solvent to be useful for microwave assisted can be assessed in terms of its dielectric constant, the larger value of the dielectric constant, the better the organic solvent's ability to become hot. Common organic solvents used in that microwave assisted extractions are acetone, acetonitrile, dichloromethane, hexane, methanol, etc. The microwave assisted extraction procedure, that is open microwave assisted extraction, that is atmosphere. The closed microwave assisted extraction, that is pressurized. Open microwave assisted extractions, that is system. The sample is located in an open vessel to which an appropriate organic solvent is added. The microwave generated from the magnetron is directed by the waveguide onto the sample solvent system. The typical operating conditions for atmospheric microwave assisted: the temperature up to the boiling point of the solvent, extractions times, power setting. These are all what? Yeah, typical operating conditions for atmospheric MAE. The closed MAE system. In the closed MAE system, microwave enter the cavity and dispersed by a mode stirrer. The mode stirrer allows uneven distributions of microwaves within the cavity. The other major differences in the pressurized MAE system is that the sample and solvents are located within the sealed vessel, which is usually made up of microwave transparent materials such as poly or trifluoro methoxy polymers. Operating conditions for the pressured MAE are as follows. Pressure is 200 Pascal air psi. The temperature is within the range of 110 to 145, and power setting is 100% at 900 watt. This is what diagram of this what MAE, microwave assisted extraction. What are the applications here? The closed vessel techniques of MAE are used for the extractions of terpenes, the imidazolide herbicides and sulfonylurea herbicides can be reported. Extractions of fungicides, that is hexaconazole via MAE from weathered soil, can also be done. Extractions of additives, propylene and polyethylene in the field of polymer research. Food processing industries uses MAE for processing of vitamins in foodstuffs. And determinations of various metals like lead, zinc and copper from soil using sequential microwave extraction procedure has been reported. These are all advantages of microwave assisted extraction. In microwave assisted extraction, extract multiple samples simultaneously using a minimal organic solvent. Reductions in extraction time, improved yield, better accuracy, and suitable for the thermolabile substances. The main disadvantages of this technique is the relatively high capital cost and maintenance of the system for effective operations. Similarly, when the target compound or solvents are non-polar or non-volatile, the efficiency of microwaves can be poor, and using high temperature can cause heat sensitive bioactive compounds to degrade. These are all the keywords, these are all references book. These are all the very important questions regarding to your point of examinations, like chelating ligand, structure of crown ether and crepes, crown ethers and important properties, cryptonds, speckled crates, anionic crepes, inorganic crepes, uses of crown ethers and crepes, the concept of solid phase extraction, and mention the factors affecting the SPE. Write a note on open MAE system and closed MAE system. Finally, advantages and disadvantages of this microwave assisted extractions. Thank you.